Hi everyone, this is Dr. GVR Seshagiri, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I will explain about shafts definitions and terminology. In previous sessions already we have learned some important terms and terminology related to shaft. In this session some more definitions we will see. So first of all, what do you mean by a shaft? So what is the function of a shaft in mechanical engineering? So actually, a shaft is a rotating machine element. So it is used to transmit power from one place to another. So it means, so wherever required power transmission from one place to another place, so that in the time so required the shaft, so from the prime source to a transfer location. Suppose long shaft is there. Suppose so generally the shaft's lengths are the 7 meters and 6 meters like that. So they should carry the power transmission from one place to another place. So many machine elements mounted on it. So due to this the additional placements of machine elements, sometimes the shaft also subjected to bending moment. So the bending moment also transfers from one place to another place along with the power. So but shaft is, as per the definition, the shaft is a rotating machine member. It means the cross section is circular. So it carries torsion and bending moment. Both will transfer. So that we will calculate the bending moment and the torsion and any additional load is acting. If acting on the shaft, that load also we will calculate. And according to design procedure, we will design the shaft. So that is the main purpose of shafts. And again, the shafts are two types. So I will explain in next slide. Next definition is axle. So what is this axle? So it is actually similar in shape to the shaft. It looks like circular and shaft cross sectional only. And it is a stationary machine element and is used for the transmission of bending moment only. So the shaft is used to transmission of bending moment and torsion, but in this case, in axial, only the transmission of bending moment is possible, and the size wise smaller one. It is a stationary machine element, so it means it is support to the rotating element. Next definition is spindle. Spindle is a short shaft that imparts motion either to a cutting tool or to a workpiece. So in case of lathe spindles, take a lathe machine. The lathe spindle is example for this definition. The short shaft. So drilling machine spindles. So what are the materials used for shaft? So the materials used for ordinary shaft is carbon steel of grades 40C8, 45C8 and 50C4 and 50C12, so etc. So generally the ordinary shaft the materials are designated like this, the carbon steels. And what are the important properties required for material selection? It should give good strength, it should give good variability and good reliability, and the material should have low notch sensitivity. So already you know the notch sensitivity factor is important while designing a shaft. Whenever the shaft is subjected to stress concentration, there two factors are important. One is fatigue stress concentration factor and theoretical stress concentration factor. So that is the relation between these two. We can write in terms of notch sensitivity, Kf minus 1 by Kt minus 1. So the material should have low notch sensitivity. So these are the requirements required for a good shaft design. So when a shaft of high strength is required, wherever high strength is required, then alloy steel such as nickel chromium, and chrome vanadium steel is used. So where high strength is required, there nickel chromium and chrome vanadium steels is used. For ordinary shafts already have explained in the previous slide. Now, how do you classify the shaft? The types of shafts are, one is transmission shaft, another one is machine shaft. The transmission shafts used in factories and workshops, industries, transmit the power from one place to another place, or one shaft to one source to the another. So similarly, machine shaft is the shaft not separately transmitting power from one place to another place. The machine itself having the shaft. So lathe machine spindle example. So here I explain briefly the transmission shaft. These shafts are transmitting power between the source and the machine absorbing power. So generally examples for this transmission shaft: counter shaft, line shafts, overhead shafts, all other remaining factory shafts are transmission shaft. So the main purpose of this shaft is used to transmit the power from one particular place, that is you can say source, to the absorbing power. First source to second source. So whereas in machine shaft, these shafts formation form an integral part of the machine itself. Example, crankshaft is example of our machine shaft, and lathe machine spindle. These are example for the machine shaft. So the machine for the shaft form an integral part of the machine itself. No need to arrange separate shaft. So what are the standard sizes of transmission shaft? The standard length of the shafts are 5 meters, 6 meters and 7 meters. As per design standards, you have to use the length 5 meters, 6 meters and 7 meters. And what is the diameter of the shaft? The diameters of shafts are, so first size is 25 mm to 60 mm is steps 5 mm step with 5 step. These are the standard dimensions of the diameters of the shaft. So how do you calculate the first range? First shaft is 25. The second step is 25 plus 5, 30, 35 with 5 step. With 5 step. 35, 40, 45, 50, 55 and 60. The first size is 25 and last size is 60. Similarly, the second size is 60 to 110 with 10 step. With 10 step, with the 10 step, I will write 60 first size, second size 70, 80, 90, 100 and 110 with 10 step. Next, third one, 110 to 140 with 15 step. So 110, 125 and 140. So remaining above for 140, you can take with 20 step. So like this, have to calculate the diameter of the shaft. Always you use standard dimensions only. The standard length and standard diameters of the shaft have to take while solving the problems. Suppose after your design calculation, your diameter, the obtained diameter is the obtained dia is 65 65.5 something example. 65.5 So what is the standard the standard diameter of the shaft? So next size is 65.5 you got. So what is the standard size with 10 step, 10 step? The next size is 70. So you have to fix the final diameter of a shaft is 70. So like this, have to take the standard sizes and lengths, the standard diameters and lengths of a shaft. So next one point is stresses in shaft. What are the stresses induced in shaft? One is shear stresses due to the transmission of torque. The transmission of torque due to the torsional load. It is a shaft is a rotational mission element. So that the torsional load will act due to the torsional load. Shear stress will be induced due to the this torsional load. So need to calculate the shear stress. Similarly, the second one is bending stress. Shear stress need to calculate. How to calculate shear stress? I will explain that. Bending stress, it may be tensile or compressive. So what are the forces acting upon these mission elements? So like mission elements, gears, pulleys, etc. All these mission elements mounted on a shaft while transmitting power. So due to the self weight of the shaft and this due to the weight of the other machine elements, bending moment will be occurred. So due to bending moment, bending stress will be induced in the shaft. So need to calculate the bending stresses, that is sigma b. The third one, stresses due to combined torsional and bending loads. Sometimes the shaft is subjected to torsional and then bending loads. So in this case, need to calculate equivalent torque and equivalent bending moment. ME and TA need to calculate. So first on the maximum permissible working stresses for transmission of shafts. So according to ASME code, the design of transmission shaft, the maximum working permissible working stress in tension or compression is maybe taken as 112 megapascal per shaft without allowance for keyways. These are the standard values megapascal in Newton per mm square. So 112 Newton per mm square, 84 Newton per mm square. So convert 1 megapascal into convert into Newton per mm square. So 1 megapascal is equal to 1 Newton per mm square. So as per ASME code, the permissible working stress without allowance for keyways is 112 and 84 allowance for keyways. So similarly, the maximum permissible shear stress 56 megapascal for shaft, that is without allowance for keyways, and 44 megapascal per shaft with allowance for keyways. So if you are giving allowance for keyways, the 42 you need to take 42 megapascal. Otherwise, its value is 56 megapascal. These are the standard values. Now coming to the design of shafts. So what are the important terms, definitions in this while designing a shaft? So actually the shafts may be designed on the basis of two types. One is strength basis and another one is rigidity and stiffness or torsional rigidity. Torsional rigidity. On the basis of strength, you can design on the basis of rigidity and stiffness. So finally, take the larger value. You can fix as the final dimensions of a shaft. So again, this basis of strength classified into various cases. The designing of shafts on the basis of strength. The following cases may be considered. First one is when the shaft is subjected to twisting moment or torque. So what are the dimensions of a shaft? How do you calculate the diameter of the shaft when it is subjected to twisting moment? There is no other the stresses and other loads like bending load. So in this case, you have to apply torsion equation. Similarly, the second case, shaft subjected to bending moment. So in this case, only bending moment. There is no other loads. You have to consider bending moment only while solving the problem. Third one is shaft subjected to combined twisting and bending moment. Both twisting as well as bending moment. And the fourth case also there, in addition to the combined twisting and bending moment, the axial load also will act. The axial loads also will act. These are the cases considered while designing a shaft. Next one is, first one, you will see shaft subjected to twisting moment. So when the shaft is subjected to a twisting moment or torque, so the diameter need to calculate by using torsion equation. So in this T by J is equal to tau by R, already you know this torsion equation. Torsion equation, what is T? Twisting moment or torque. J, polar moment of inertia. And tau, shear stress. And R is the distance of topmost fiber from its neutral axis. So J is equal to polar moment of inertia. You can calculate by using this relation 5 by 32 into d to the power of 4. So where D is diameter of the shaft. So now you can calculate diameter T by J is equal to tau by R. So write the equation 5 by 32 into d to the power of 4 is equal to tau by d by 2. So d get cancelled and 16. So that T is equal to 5 by 16 d cube into tau. This is the final equation when the shaft is subjected to twisting moment. So now apply this equation and find out D. Similarly, second case, shaft subjected to bending moment. So when the shafts are subjected to bending moment, then the maximum stress, it may be tensile or compressive, is obtained by using bending equation. So what is the bending equation? M by I is equal to sigma B by Y. So the full equation is M by I is equal to E by Y is equal to E by R. So here M is bending moment, I is moment of inertia 5 by 64 to d to the power of 4. Y is the distance of topmost fiber from its neutral axis. Sigma B is the bending stress. So you can write the bending stress is equal to M by I into Y, or sigma B is equal to M by I by Y. M by I is equal to sigma B by Y, or sigma B is equal to M by I into Y, or sigma B is equal to M by I by Y. So M by Z, section modulus, you can say like this also, section modulus. So now apply this equation for problem solving. You will get the bending moment M is equal to pi by 32 into sigma b into dq. This is the final equation. So by using this equation, calculate dia. Next, shaft subject to combined twisting moment and bending moment. Suppose when the shafts are subjected to combined twisting moment and bending moment, sometimes many loads are acting on a shaft. In that case, it transfers torque, twisting moment, and then bending moment as well as. So in this case, you need to apply the principal stress theories. Suppose when the shaft is subjected to these combined loads, the shaft must be designed on the basis of two movements simultaneously. So that is, it based on two theories, you will calculate the diameter of the shaft. So already you know the maximum shear stress theory are also called as gauge theory. This theory is used for ductile materials. What are the ductile materials? So the mild steel. Maximum normal stress theory, Rankine's theory. So it is used for brittle materials. Example for brittle materials, cast iron. So to apply these two theories and calculate the diameter of the shaft. First apply the maximum shear stress theory according to maximum shear stress theory. So what is the diameter of the shaft when it is subjected to twisting moment and bending moment? Similarly, calculate the diameter of the shaft according to the maximum normal stress theory or Rankine's theory. So calculate diameter. So take the larger one as a final diameter of the shaft. The first case, according to maximum shear stress theory, according to gauge theory, the shear maximum is equal to half square root of sigma b square plus 4,000. What is this bending stress? So already we have calculated in the previous case. M is equal to pi by 32 into sigma b to dq. So sigma b is equal to 32 m by pi dq. Now substitute this sigma b value in this equation, and the shear stress pi by T is equal to pi by 16 shear stress into dq. So shear stress is equal to 16T by pi dq. Now substitute these two values in this and calculate the final diameter. So final equation obtained like this: pi by 16 into tau maximum into dq sigma m square square root of m square plus t square. This term is called as equivalent twisting moment T. So you can write T is equal to square root of m square plus t square is equal to pi by 16 into tau max into dq. What is T? T is square root of m square plus t square. Similarly, write the equation according to maximum normal stress theory. The maximum normal stress theory, sigma b max is equal to of sigma b plus of square root of sigma b square plus 4 tau. So additionally, the sigma b by 2 term we will add. So in this equation also substitute pi by 32 into sigma b max into d cube is equal to this equation of into m plus square root of m square plus t square. This term is called as equivalent bending moment, ME. So that you can write ME is equal to pi by 32 sigma b into d cube. So by using this equation, find the diameter. And finally, you will get one diameter, two diameters you will get. So take the larger one from the above calculated values. So that is fixed as a final diameter of the shaft. So which one is highest value you identify, and that value you can say that is the final diameter of the shaft. So according to the maximum normal stress theory and shear stress theory, whenever the shaft is subjected to combined loads. So next one is, sometimes the shafts are subjected to fluctuating loads. Already you know, we have discussed in fatigue topic, fluctuating loads, cyclic loads. They fluctuates, it varies loads from minimum to maximum. So subjected to combined bending and torsion, the equivalent twisting moment already you know, T is equal to, so without this term, T is equal to square root of m square plus t square. M is the bending moment and T is the twisting moment. So when it is subjected to fluctuating loads, need to multiply some factors. That is, these factors are the Km and Kt, bending moment factor and twisting moment factor. These two also depends upon the nature of the load. It may be impact, it may be stationary, it may be shock loads. You have to take the standard values from the table which is available in the design data book. Similarly, an equivalent bending moment. So normally bending moment is of equivalent bending moment is m plus square root of m square plus t square. So in this multiply these two factors. One is Km is combined shock and fatigue factor by bending loads. Kt is combined shock and fatigue factors for torsion. So multiply and you will get the actual bending moment and then twisting moment. So whenever the shafts are subjected to fluctuating loads. And calculate diameter, same as previous condition. Up to now we have discussed the design of shaft on the basis of strength only. Strength basis, different cases are there, already we have discussed. The second one is design of shafts on the basis of rigidity. the torsional rigidity. So this type of design, torsional rigidity, is important in the case of camshaft in IC engine. To opening and closing the valves, this camshaft plays a very important role in automobile engines. So the permissible amount of twist should not exceed 0.25 degrees for metal length of the such type of shaft. So this the valve opening and closing arrangement is arranged in an engine with the help of rocker arm. The camshaft attached to the rocker arm. So rocker arm shaft, the length, that permissible amount twisting, the how much twisted while applying load, so should not exceed 0.25 degrees. So then how to calculate the deflection? By using this torsion equation. So T actually the torsion equation is T by J is equal to tau by R is equal to G theta by L. This G is torsional rigidity or modulus of rigidity. So G or C. It depends upon the material. So by using this equation, find out angle of twist theta T by J multiply with L by G. T is twisting moment or twisting moment or torsion, and then J is the polar moment of inertia. Already you know, 5 by 32 into T to the power 4. Ln and G is the modulus of rigidity and theta angle of twist. So calculate angle of twist by using this equation. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.